Hello, I am Catherine Plaisant, and this is Vinit Jain from the Human-Computer Interaction Laboratory of the University of Maryland. We will show you how you can use dynamic queries to explore data, in this case health data, as we are working with the US National Center for Health Statistics. Typically, statistics are tables of averages, bar charts, graphs, and also long pages of numbers. In the field of epidemiology, which deal with the incidence, distribution, and control of diseases, maps are often used to identify geographic clusters and eventually find similar patterns between maps. For example, these show rates of cardiovascular disease mortality, and this map, which has a similar pattern, shows the percentage of the population working in manufacturing. The most famous example is this map, which showed how all the cholera cases in 1854 in London were linked to a single water well. There are now atlases like this Cancer Mortality NIH Atlas. It is an impressive collection of maps, but access to details is lost since everything is split in only a few categories, here 5. So I cannot tell what is the cancer rate in my county. To show trends on paper, graphs or series of maps are used. This work shows the spread over 6 weeks of an influenza-like illness in France. Computer programs have been also used to generate canned animations, which are very powerful to illustrate trends. Geographical information systems are now becoming more available. They are powerful, but often still slow to use, and mainly oriented towards the generation of maps, more than the casual and fast browsing among maps. We believe that giving fast access to maps and the direct control of the animation can help researchers to engage in exploratory tasks such as hypothesis formulation. How can dynamic queries help? Dynamic queries apply the principle of direct manipulation to querying. Direct manipulation implies a visual representation of the world of action, rapid, incremental, and reversible actions, and immediate and continuous feedback. Dynamic queries are user-controlled animated displays of spatial or textual data. One of our first applications was a DC home finder, which helps locate in a few seconds a subset of houses that match the query, which is interactively adjusted. Our experiments have demonstrated that dynamic queries were very powerful in finding trends and exceptions. For the National Center for Health Statistics, dynamic queries were immediately recognized as an excellent tool to explore health time trends. Let's look at the prototype. Here, we have mapped cervix cancer mortality rates for white females. Bright red means high rates. Low rates are blue. On the side, a time slider let me change the year for which data is displayed. When I slide from 1950 to 1970, I can clearly see that things are globally improving, reds being replaced by blues. In the case of cervix cancer, this is probably due to the increasing use of pap smears, which allows early detection and treatment. Opposed to the paper maps of the traditional atlas, I can access the exact values easily by clicking where I want. I can also pose some simple queries, like give me the only states with a high percentage of college-educated people and a large number of smokers. The side sliders act as filters, and the states that do not answer the query disappear from the map. As you could see, not too many states answer that query. I want to mention that this is working on a 386 PC, and that the animation uses color palette changes. It shows that it is becoming possible to do animation and explore data interactively on common machines. But the hidden benefit of such an interactive tool for the researcher might be the possibility of seeing correlations by looking at the patterns of disappearance of the states. For example, when I slide this slider which filters on the average income, I am making disappear the high income states first, and only the low income states remain at the end. I do it again. Look at the reddish states. Notice that they stay until late, suggesting a possible correlation. The same thing seems to happen for the percentage of college-educated population, probably because high-income and college-educated women are more likely to be followed by a doctor and seek treatment. Our newer prototype uses smaller areas. We're facing speed issues because we wish to keep working on common 386 equipment. But zooming is possible to keep fast animation. And we are optimistic that new development will make it possible to keep real-time animation like this, which is necessary to dynamic queries. Animated maps are a powerful tool to prompt scientific insight and illustrate findings in a convincing manner. We demonstrated that it is now possible to give the direct control of the animation to the user while keeping access to detailed data and a simple querying mechanism. We are looking for other techniques to provide grand tour of large amount of data to help discover patterns and identify possible correlations. Thank you.